You are watching video on SEE Class 10 Subject Science. In this video series, we are going to study chapters of Physics, Chemistry, Biology, Astronomy and Geology. Now this video deals with Physics, chapter 4, and this is part 5 of the chapter. Now in this part, we are going to study acceleration due to gravity, small g. Now, acceleration means when velocity of a body in motion increases. When velocity increases, that case is called acceleration. Sometimes it may decrease also, that is negative acceleration. Okay, now velocity means speed in a particular direction. So the speed of a body, moving body increases, that is called acceleration. Okay, sometimes it may decrease, that is negative acceleration. Now we are going to see acceleration in case of a falling body. When body falls downward towards the surface of the earth, there will be increase in velocity, and that velocity is acceleration. Now we are going to study that. Look at this example. This is the stone lifted at this height. Now it is going to fall down. Okay, at this moment the stone is not moving, it has not started to fall down. That is why velocity is 0 meter per second. Now the stone is released and it starts falling downward. After 1 second time, if you measure the velocity, it becomes 9.8 meter per second. And again next 1 second time, velocity 19.6 meter per second. Again next 1 second time, velocity 29.4 meter per second. And after 1 second time, again 39.2 meter per second. So velocity has increased by 9.8 meter per second. That is why it is acceleration. Now you see the velocity has increased at the uniform rate, uniform manner, 9.8 meter per second. 9.8 meter per second. That is why it is uniform acceleration. Uniform acceleration, because velocity is increasing at the uniform rate. Okay, now you see the velocity of a falling body is increasing as it falls downward. Okay, when the stone is going to touch the ground, at this time its velocity is maximum, because it has been increasing from starting to end. Okay, so 39.2 meter per second maximum velocity. Now you see the velocity is increasing in the falling body, falling downward. Now increase in velocity is due to, what could be the reason? It is pulling force of the earth. Now we know what is gravity. Gravity pulls the body towards the surface of the earth, or towards the center of the earth. Okay, so pulling force of the earth is causing this increase in velocity. Okay, that is why it is acceleration, because of gravity. Gravity is pulling the body downward and it is increasing the velocity of this falling body. That is why it is acceleration due to gravity. Now we'll see the definition of acceleration due to gravity here. Acceleration due to gravity is defined as the acceleration produced in a freely falling body due to the force of the gravity of the earth. Now it is denoted by small g, symbol is a small g, and SI unit is meter per second square, and average value on the earth's surface of acceleration due to gravity is 9.8 meter per second square. The value of g on the moon is 1.67 meter per second square, and acceleration due to gravity on the Jupiter is 25 meter per second square. Why do we have this different values for small g? We are going to study that in next part. Okay, now from this part a common question is asked. Okay, velocity acceleration due to gravity on the surface of the earth is 9.8 meter per second square. What do you mean by the statement? Explain. So the meaning of this statement is velocity increases by 9.8 meter per second in every 1 second time when air resistance is neglected. Okay, so acceleration due to gravity on the surface of the earth is 9.8 meter per second square. Its meaning is velocity increases by 9.8 meter per second in every 1 second time, just like this. Okay, it is the explanation. When air resistance is neglected means when we do not consider any disturbance on the way to fall downward. There is no disturbance when the stone is falling downward. Okay, when air resistance is neglected, any kind of disturbance or the resistance is not considered, not even air resistance. Okay, so here Acceleration due to gravity is defined as the acceleration produced in a freely falling body. Freely falling body means the body falling with full speed. Freely falling body without any disturbance, falling down with full speed. That is called freely falling condition. Okay, now this is acceleration due to gravity. Now we'll see an interesting activity related to acceleration due to gravity, and we are going to understand more about acceleration due to gravity. This experiment was done by Robert Boyle after Galileo's death, and it is known as coin and feather experiment. Okay, now in many cases we have seen that lighter bodies fall downward slowly, slower than heavier objects. Okay, we are going to understand this phenomenon. You see, Robert Boyle took two objects in a long cylinder. Objects were feather and coin, a heavier coin, bigger size coin. Okay, and he made to fall these two things together at the same time. Okay, in the first case he kept air, he allowed air to be present in the cylinder, and in the next case he made the cylinder vacuum, completely vacuum. Vacuum means not even air is present. Okay, air is also taken out from this hole and it is made completely vacuum. Okay, not even air is present, air is not present in this, that is why it is vacuum, it is completely empty. So in the first case what happened was, when there was air, feather fell slowly, much slower than coin. Okay, coin fell much quicker than feather and it touched the bottom. Okay, much quicker than feather, whereas feather fell down slowly. Okay, when there was air. But when there was no air in the cylinder, when it was vacuum, what happened is feather and coin fell at the same time. Okay, both of these touch the bottom of cylinder at the same time. So the what could be the explanation of this activity? In the first case, feather has larger surface area than coin. Okay, feather is much lighter, its weight is much less, and it has larger surface area. So when it started falling down, air resistance, upward air force was acting on the surface, larger surface of the feather. Upward air resistance or upward force was more or less equal to the weight of the feather, so it was, restricting feather to fall down freely. Okay, upward air resistance was trying to balance the weight of the feather. That is why feather fell down slowly, whereas the coin, it has heavier weight and it has much smaller surface area than coin. Okay, because of smaller surface area, upward force of air acting on it is much smaller, because small area and small air resistance is acting on its surface from downward. That is why the weight of the coin was much bigger than upward force of the air. That means it was, the coin was falling down without any disturbance. Okay, so the coin fell freely because of its more weight, whereas feather fell down slowly because upward air resistance was acting on its surface because of this larger surface area, and it has smaller weight, it is much lighter, right? So because of this reason, feather fell down slowly and coin fell down much quicker. Right? Now in the other case what happened is, coin and feather fell together because there was no air resistance, no upward force to balance the weight of feather. Okay, that is why there was not any kind of resistance, not even air. That is why both of these objects fell at the same time. Okay, so you see, what do you understand, what could be the conclusion of this? How can you state the conclusion of this experiment? Conclusion: in absence of air resistance, all bodies, heavier and lighter, fall at the same time. So from this we can understand, no, in absence of air resistance, when there is nothing to disturb the speed of falling down body, absence of air resistance, not any kind of disturbance, not even air, all bodies, heavier and lighter, all kind of bodies, fall at the same rate. Okay, the falling down rate is same, speed is same when there is no air resistance. Okay, in absence of air resistance, all bodies heavier and lighter fall at the same rate. So this is the conclusion of coin and feather experiment. This is asked in exams frequently. What is the conclusion of coin and feather experiment? The conclusion of coin and feather experiment is, in absence of air resistance, all bodies heavier and lighter fall at the same rate. Now we are going to see next experiment, which also supports to understand acceleration due to gravity. Falling bodies and acceleration due to gravity. So this experiment was done by Galileo in 1950 AD. He did this in Leaning Tower of Pisa in Italy. Okay, and what he did was he released iron balls of different masses, sizes at the same time. And what he found was all of them reached the ground at the same time. Okay, a small iron ball, big iron ball, all of them fell at the same time. So all bodies of different masses fall with the same acceleration when air resistance is neglected again. Okay, now whereas in the other case, what happened is, if feather was, feather and coin were made to, iron ball were made to fall together, then it would happen this way. It could be the result. Okay, so it is because feather falls much slower than iron ball due to larger air resistance on its surface. Just like in previous case, the weight of the feather is much smaller, and upward air resistance on its larger surface area is much more compared to the coin. So this upward force is blocking, trying to balance the weight of feather. That is why feather is falling down slowly, whereas coin or the iron ball is much heavier. Upward air resistance is very small, negligible in this case. That is why this iron ball falls with the acceleration due to gravity, means it falls with full speed. Okay, so in this case, all of the iron balls, they have different masses. Okay, but they fail at the same time. It is because in each case, whether a small iron ball or big iron ball, upward air resistance is negligible compared to the weight of this iron ball. Okay, the surface of iron ball is small, and upward air resistance is very small because of small surface area, and at the same time weight of iron ball is much more than upward air resistance. Okay, so in every case it is free fall. That means every iron ball falls freely without any resistance in the middle, not even air resistance. Okay, so you see what could be the conclusion of this experiment. Two bodies, one heavier and another lighter, fall freely at the same rate if there is no air resistance. So here also same case, heavier and lighter bodies fall at the same time if there is no air resistance, right? So in vacuum, feather and iron ball fall at the same time. If this experiment was done in vacuum, then you could have seen that feather and the iron ball, these two are falling together. Okay, but it is done in presence of air. That is why feather is falling down slowly. So this means the acceleration due to gravity, the rate of falling down, speed of a body falling downward, does not depend on mass of the body. Heavier and lighter bodies fall at the same time. Okay, now we understand more this way. So here is a small part. Parachute does not work on the moon. Interesting statement. Okay, parachute does not work on the moon. Paratroopers cannot do anything on the surface of the moon. Right, now let's think, does parachute work on the earth? Yes, parachute works on the earth. Okay, we have seen paratroopers falling down with parachute, open parachute. No, so in our country there is paragliding and people fly carrying parachute. No, so parachute works on the earth, but parachute does not work on the moon. There is absence of atmosphere on the moon because moon does not have atmosphere on its surface. So no air resistance or upward force is acting on the falling bodies on the surface of the moon. There is nothing to balance the weight of falling down body on the surface of the moon. That is why parachute also falls freely. Parachute falls straight down on the surface of the moon with the acceleration due to gravity. Okay, falling down with full speed means that is equal to the speed of acceleration due to gravity. Thus, parachute does not work on the moon. So again, there is absence of atmosphere on the moon. So no air resistance or upward force will be exerted on the falling bodies. Parachute also falls freely with the acceleration due to gravity, means with full speed. Thus, parachute does not work on the moon. So with this we finish this part, and we are going to study g equal to gm by r square in the next part.